Attention mechanism is a simple mechanism to solve the problems of classical architectures like RNN and LSTM, which processes the text sequences in a sequential manner, that is word by word and embedding by embedding. So, as the seq sequence length increases, the performance tends to decrease as the context vector cannot store the meaning of the entire sentence. So it starts to forget the context from the initial words. So that was the exact problem that attention is designed to resolve. So it asks a simple question: what builds the context for the current word? For an example, cafe was great but Wi-Fi was poor. Here, cafe and great are highly related to each other. Means great is providing some context about the cafe, and Wi-Fi and the word is providing some context about the token Wi-Fi. But was there were two was and one but is providing less context to the word cafe and the word Wi-Fi. So therefore, we we are computing energy scores for each token to every other token to know how much a token is related to another token. So the internally the attention mechanism builds a n cross n matrix, and n cross n we have energy scores to know how much for each word, how what are the most what are the what are the words that matters the most to that word. So from the high energy score words, the meaning of the words has been captured. So that's how uh, the meaning of the word has been captured in now, and that's how the attention mechanism resolves the problem of the limiting context memory by looking at words that are important, not the entire matrix, not the entire sentence. It only looks at the words that matters the most. Now, attention mechanism is also a parallel mechanism, that is, it can process the each token parallelly. It doesn't have to wait for the previous token to complete the computation. So it is faster and more accurate than the previous architectures. So that's how it solves the problem of the limiting context.